Hi Physics fam, we are going to do another kinematic equation problem. We have a bobsled team accelerating the sled to go up to 150 meters per second in 3 seconds from rest. We're trying to find the acceleration and the distance the bobsled team has traveled. So again, we're going to start with identifying key pieces of information. We know that we're going to go up to 150 meters per second over a time period of 3 seconds, and we're starting from rest. So we can't just look for numbers because other information is going to be important as well. The first part is asking us to solve for acceleration, and then the second part is going to be asking us to solve for distance. So let's go ahead and list out the variables we have. We have initial velocity, so how fast we're starting at the beginning, and that was 0 meters per second, right? They told us that we were starting from rest. And then we get up to a final velocity of 150 meters per second, and this occurs over a time period of 3 seconds. And then we are trying to find our acceleration, and then how far we've traveled. So we're going to start with part A, asking us to find the sled's acceleration. So if we look at our formula sheet, we know that we have to use an equation that has acceleration in it. So that's going to be equations 3, 4, and 5. So if we look at the information that we have, we know nothing about our position at all. So we can't use the third equation. So we now have to look at the fourth equation. And that has acceleration, so that's good. We've got velocity and time, so that's what we're going to use. So we have acceleration equals change in velocity over change in time. Again, we can rewrite this to say v final minus v initial over time. Totally up to you how you want to organize it. So we have acceleration is equal to 150 meters per second minus 0 meters per second, all divided by 3. So we can go ahead and just divide those here, and we end up with an acceleration of 50 meters per second squared. And that is our answer for part A, what the sled's acceleration is. So now we can put that information in our data table to help us solve for the distance the bobsled team has traveled. So now we pretty much have every single variable except for delta x. So it's up to us to decide which equation we want to use. So let's go ahead and use the very last one. We haven't seen that one yet. So the last one is v final squared equals v initial squared plus 2a delta x. So we can plug in all of the variables that we have. So v final is 150, and we're going to square that. V initial was 0, so we can just get rid of it. And then we have 2 times the acceleration that we just solved for, of 50, and then we're solving for delta x. So putting into our calculator, 150 squared gives us 22,500, and that will equal 100 times delta x. So we'll just divide both sides by 100, and we end up with 225 meters for our displacement. So if you're having trouble figuring out which equations to use, that's totally fine. You can try any of them, and then if you realize that you don't have the right information for them, you just scrap it and move on to a different one. That's why it's going to be so important to have your units memorized. So if you know the units for all of your values, velocity, acceleration, displacement, and time, we should have a much easier time getting used to these new equations. And as always, we're going to need a lot of practice before we're able to do it quickly. Good luck, physics fam!